All right, so 7:05. I guess we'll get started. Welcome, everyone. My name is Dr. Bednarz. I'm an associate professor in the mechanical engineering department at Wilkes University. So welcome to our Accepted Students Day presentation. Feel free to turn on your camera so you can see your smiling faces along the way. I put an extra note in the chat that if you have a question as I'm going in my presentation, it's probably best if we wait till the end, just so I don't lose my train of thought. I kind of continue on through to the end. But maybe if you think of it, just type in the question now, and then when I get to the very end, I'll be able to kind of go through whatever questions you guys have. I'm here with Liz, and she's from admissions, and we were just kind of chatting beforehand. So this is great because a lot of questions, I typically get for open houses or admissions related. So I think this will be wonderful. Hopefully Liz could help you out. All right, so let me go ahead and get started. Okay, so again, welcome. So a little bit, I'm going to talk about myself, just so you know who I am. I'm from Hazleton, so I'm a NEPA born and raised. Then I moved to Maryland for 8 years, came back to Northeast Pennsylvania. I was actually a mechanical engineering student at Wilkes from 97 to 2001. So that's going to be extremely relevant because I'm going to talk about the kind of things that I did with my Wilkes engineering degree. So, not only do I teach at the school now, but I think I've done some pretty cool things in my career right out of my bachelor's degree from Wilkes. Some of the professors are still around, so I can relate to the current students since I've been in your shoes. Here's what I looked like back in the day, back in college. I actually, I kind of go back and forth, growing a beard, shaving it. Right now, I'm sporting my chin goatee that I had in college. Maybe it was subconscious because 20 years ago is when I graduated from Wilkes, so I don't know. Some things I did at Wilkes, I played on the tennis team. I was involved in campus interfaith. So, the reason I bring that up is mechanical engineering is definitely a challenging major for sure. It's 130 credits. I'm going to get to the curriculum, and it's going to involve a lot of your time. Obviously, you're going to be studying, doing projects. And you may sometimes feel like you don't have any free time. But if you balance what's due and balance your time, you could get involved in other clubs, activities, sports. We've had students play on, any of the sports teams we have at Wilkes: basketball, football, lacrosse, soccer. I'm trying to just think of my advisees and the different teams they've played. Baseball is very popular. There's other clubs. We have Mechanical Engineering Club, ASME is a great one to get involved with. The key to college is balance your time, prioritization. This is a great, transition into the real world. Parents aren't going to be there constantly to tell you to do your homework. I have a 15-year-old son, and he's pretty good at doing his own work, but yeah, I'm kind of still there, saying, hey, did you get your work done today? Do you have any projects coming up? So, when you get into college, especially if you're dorming and you're moved away from home, you're an adult. This is, your turn to kind of step it up and get what you got to get done to look forward to your career. So as I said, I think it's very relevant. What did I do with my Wilkes engineering degree? Right out of college, I was fortunate I got a full-time job working as an Army civilian, as a mechanical engineer. So I got to live out my dream of calling myself an inventor. If you're not really sure what an engineer is, hopefully by the end of this talk, you'll really understand. But engineering design is about taking something that doesn't exist and in your mind, making it a reality. That's, if you're wondering, what's this talk mean? What does engineering design mean? This is what engineering design is. You're an inventor, you're a creator, you're an innovator, you're someone that changes the world. I also went on to graduate school while working. That's kind of how I'm able to do what I do now. I got my master's degree and my PhD part-time while working. And that sort of led to my current teaching position, which is even more of a dream for me. I truly love what I do. Hopefully it comes through in my talk as well. Just quick academic background. Again, graduated from Wilkes 2001, then UMBC with my master's and PhD along the way. And here's my first graphic. We're going to emphasize the Wilkes because that's kind of what pays the bill in my family, but also I love the school. I'm going to talk about why I decided to come back to Wilkes. I had different opportunities around the country, and I truly wanted to come back to the culture we have here at Wilkes. Okay, a little bit about my professional background. Again, I think this is also relevant, showing some of the things that you can maybe do as a mechanical engineer in your career, as well as, I was a product of the Wilkes system, and I got on to do, all these cool things. So I worked for the Aberdeen Test Center in Maryland, and I worked there, like I said, 8.5 years. My primary mission was I designed outriggers for vehicles. That's on the left. So basically, I drew up this aluminum beam that you see with the shock absorber and the plate so that we can conduct lane change maneuvers at high speeds without worrying about rolling over the vehicle. So it was basically a safety equipment for testing purposes to protect several $100,000, perhaps millions of dollar pieces of equipment, and more importantly, the drivers. We don't want anyone to get hurt while they were trying to conduct this important testing. I also designed these modular platforms for ballistic testing, and you're going to see that on the right. That was made out of 80-20. So I love 80-20. I love working with it. It's kind of like an adult erector set. So you have these different aluminum extrusions with these plates that you could slide back and forth and tighten up the nuts. So mechanical engineering, it could be a very hands-on field. That's one of the reasons I like it. You're doing math and physics and design, but you can also turn some wrenches at the end of the day too. So I think it's a great combination of all these different aspects. All right, then I transferred up to the Poconos in Pennsylvania. I worked for Toby Hanna for 3.5 years. So I worked on the environmental stress and screening lab on the left, which provides temperature vibrations testing. Probably the most fun job I worked on was this 3-spar assembly for a radio solar telescope network that was installed in Hawaii. And it doesn't really look like much for design, especially if you look back at my previous designs. They were much more intricate, much more complicated. This was pretty simple. It was just a composite tubing with the aluminum 3-spar at the top to hold the signal. The coolest thing about this project was I actually got to go to Hawaii and do the installation. So here's a picture of me up on a 50-foot bucket lift on a 1,500-foot cliff in Oahu. Trying to install my design in the back. So I love that picture. It's just Hawaii was fun to go to. So I put this at the top. Yes, I got paid for that too. So sometimes in engineering you get to go on travel across the country or across the world. So definitely an enjoyable perk of the profession. So this was another project I worked on at Toby Hanna. It actually led to my first patent. I'm fortunate enough, multiple patent holder. So this was a safety brace for a radar system, basically. It looked kind of like a dump truck bed that went up in the air. And it was to prevent someone that was working on it from getting injured or even killed because the antenna weighed 2,000 pounds. So it's just kind of an aluminum tubing with a hinge system and a clamp. And it went over top of it. And I was fortunate enough, like I said, to be awarded a patent. So what does it take to get a patent? So I like focusing on this design a little because I could, maybe answer some questions of, what do you do day to day as an engineer? All right, so one thing we could use computer simulations. That's one of our tools we use. So I modeled what it would look like with this antenna up in the air with different winds blowing on it, and they would generate a force that would try to blow it over and try to push on the brace that was holding it up in the air. So this was a particular program, CF Design, that was used to calculate the force from the wind. Then I created what's called a free body diagram. This is actually something you learn early on in your engineering career. What you're seeing with those arrows, they're called force vectors. So that's kind of showing all the different forces that are acting on this antenna to keep it in static equilibrium so it doesn't fall over. The wind's blowing on it to the right, FW. Gravity always pulls down. That's a nice constant. Fg is force of gravity. And the force from the brace is pushing back. So engineering does involve a lot of math and a lot of physics, obviously. So this is something you could do even sophomore year, third semester class, statics, you learn how to do free body diagrams and calculate different forces to maintain static equilibrium. So this is kind of showing that aspect. Okay, now that I knew the force that was acting on the brace, the next step is we want to say how to design it so it doesn't break. So we can do some hand calculations and determine the stress within the beam and compare that to the threshold of the different materials. So we can choose steel, aluminum, titanium, and engineering takes 4 years of schooling to get there because there's no right answer. It's not like saying 2 + 2 = 4, right? You could make an argument why I would want to make this out of steel versus aluminum versus titanium. It kind of boils down to cost, corrosion resistance, machinability, strength, weight. So there's all these factors that go into picking what should this design look like. All right, so as I mentioned, we could do some of these by hand, these calculations by hand, or we can also use a computer-aided program called Finite Element Analysis, FEA. So we actually do have a course junior year that shows FEA. All right, so now that I was happy with the design and had an adequate safety factor, then we went and built a plastic prototype, and I'm going to show a little bit of that in the next slide. And I was also able to coordinate physical testing back at my old home down at ATC in Maryland to verify that the safety factor was indeed greater than 10, so it would be very safe in the field. And the braces are currently being manufactured for deployment in the field. Patent was awarded. Very successful project at the end. Hopefully it's saving lives currently. All right, so as I mentioned, I made a plastic model first, and the point of the plastic model was to test the form fit function of the final design without having to make it out of metal. So we didn't want to shut down another production line just to make this one-off prototype that may or may not fit as we think it would. So we used additive manufacturing, which is also called 3D printing, which is also called rapid prototyping. So there's a lot of different words for kind of the same thing. And when I was working on this project, probably a decade ago, more or less, additive manufacturing was still kind of an emerging field. And now it's everywhere. There's probably some of you that have used 3D printers at your high school, or you may even have one at home. You could buy your own 3D printer for a little more than the cost of a 2D printer on paper. So it's very exciting where this field is going. So we actually do have a major 3D printing lab at Wilkes as part of our lab facilities, which I will talk about later in my my talk. Okay, so you can kind of see the process of the 3D printing. It lays down this plastic layer by layer, line by line, and anytime you're trying to print the plastic over top air, it's going to want to just drop down. So you need to fill in this black support material, which then needs a post-processing, it's called. So you remove it in a chemical bath, ship it off, and then it's ready to go. Typically, if I was to hold this talk in person, I would kind of pass this around the room, but that's sort of what it looks like. It's about 10 inches long, and I actually did 3D print it so that it's movable. So we really did take it and clamp it over the lead screw, made sure it missed the bolt. That's what this notch on the right-hand side you can see is for. Was the handles ergonomic? Can we get the pin through the holes? So once we were satisfied with that, then we moved on to the next phase of making it out of metal. All right, another patent I got when I was working for the Army. This is for a deflection plate, which was mounted under a mobile dynamometer. It's basically a huge truck that could pull tanks and see how much force it took to pull them. And the purpose of this deflection plate was to make sure this load cell wasn't overloaded and we wouldn't damage a pretty expensive piece of equipment. So I kind of did this custom taper design out of very high strength aluminum alloy, and I was fortunate enough to get another patent on this. Another project I worked on for the Army, which was really fun, I worked on this down in Maryland. This is called the Bridge Crossing Simulator. So I bring this one up because this project led to my dissertation, which was the huge project I worked on for my doctorate, but also kind of continuing research and what my lab is all about now. Inverse problems, strain gauges, force identification. So, that's kind of where it all got started. Maybe 2003, I first started working on this project. So it's what you see there, this big blue and yellow machine, which happens to be Wilkes colors, ironically. So that's another reason I kind of like showing this picture. We were testing this portable army bridge, the green thing, with a series of hydraulic cylinders. So they would push down in like a leapfrogging sequence to simulate a tank going over them. So this was a safe way of doing fatigue testing, which is a concept in engineering. Sometimes something won't break after one cycle, but it may break after tens of thousands of cycles or hundreds of thousands of cycles. So, it's something to keep in mind as part of your engineering design. And here's a picture of me in my office at Wilkes, kind of overlooking the Greenway area, with holding some of my patents. And my third patent was for the force transducer related to the BCS work. All right, so I talked about my career with the Army, working as a mechanical engineer for almost 12 years total, and then I came back to Wilkes, and I call it home. And it's a great rendering of Stark Learning Center. That's kind of our engineering building. And looking at the Greenway, I used to play football in the Greenway with my buddies in college. We had winter weekend events, a lot of fun community events, with your colleagues, while you're a student, if you choose to get involved, which I highly encourage. So I got my foot in the door in 2010 while I was finishing my dissertation. So I was kind of busy at the time. I had a 4-year-old son. I was working full-time at the Army. Then at night, I was driving to Wilkes, which was an hour from the Poconos, in order to teach night classes. But it was fun, and I was finishing up my PhD, so life was busy. Okay, so here's kind of a practical slide, I like to call this. So I talk about a lot in this talk about all the fun things you could do as an engineer, and why it's a rewarding career from philosophical standpoint, or just satisfaction standpoint, that you feel like you're making the world better, which is absolutely wonderful. But it's also financially rewarding. So these are actual numbers, and why become a mechanical engineer? Well, you could think of what the average person considers high-paying professions. My son's a doctor or a lawyer. But look at the median salary for mechanical engineers, and this is even a little dated. This is from 2014. $83,000 is the average salary for mechanical engineers nationwide. And you may even think to yourself, oh, well, this is a very low cost of living area, Dr. Bednarz. This is Northeast Pennsylvania. Nobody makes that much money. There's engineers that come out of Wilkes getting jobs in this area, $60,000. I know, they talk to me. They say, yeah, I just got a job, and this is what the company offered me. So that's fantastic. That's maybe double what the average family could earn. So it's a very financially rewarding career. It's hard to get there. There's a lot of work and struggles to get there, but it's a definitely rewarding career. It's worth the cost of college. How about job potential? Again, it's the number one job nationwide, mechanical engineering. I don't know if you've seen that, as you're doing your research, what to do getting into college, but you have mechanical engineering as the number one profession. Electrical engineering, I believe, is 2 or 3. Civil engineering is up there. The reason I bring that up is we are actually bringing a civil engineering program online at Wilkes University, starting, I believe, this fall. So we already have civil engineering, sort of a mesh between mechanical engineering and environmental engineering, which is another hallmark program we have at Wilkes. We have mechanical engineering, electrical engineering, environmental engineering. So we're bringing on the civil engineering program because it allows us to partner up with the environmental engineering professors in their labs and our labs. So a lot of options. And I'm going to talk about that when I get to our actual curriculum, how you don't necessarily have to pick one engineering and stick with it 4 years. You could start out electrical for the first year and then switch to mechanical and still graduate in 4 years, or any of these combinations that I mentioned. Okay, so I started talking about the job potential, 277,000 jobs, 2014, predicted to grow to 290,000 by 2024, continuing to grow from there. There's always going to be a need for design, and especially as technology becomes more and more intricate, right? The emergent fields of 3D printing, robotics, artificial intelligence, the Internet of Things. These are all things that'll drive that growth in mechanical engineering as a profession. I think it's the most versatile of all the engineering majors. Just do a monster search. Now, listen to me now, if you don't mind. But when we hang up here, do a search for jobs nationwide. Just talk mechanical engineering in whatever town you're calling in from, and you're going to see how many jobs pop up. Okay, so here, I talked about the financial, but what's another reason to do engineering? Are things made of stuff? Philosophy is stuff. Engineering, awesome stuff. Could it be more awesome? We got a giant laser. We got ultra space jets. So, I really think that engineering is, it's financially rewarding, but it is fun, and it's, you always feel like you did a good job for humanity at the end of the day. All right, so now's the time where I get to talk, some technical about our curriculum. And we're ABET accredited curriculum, which is the Engineering Accreditation Board nationwide, and we've maintained our accreditation continuously for the last 30 years, whenever our program was founded. So our program has been through some revisions along the way. We try to always stay current to the times, and we need a balance of math and science to engineering technical courses. We do a lot of hands-on lab. I'm going to talk about that later on, but I truly think that's one of our hallmarks of mechanical engineering at Wilkes. If someone had to say, hey, what makes you different? Why should I go to your school and not the competitors in Pennsylvania or outside this area? I think we have strong foundations in the theory. You're going to learn from a classroom setting, and you get to do design projects and calculations and computer simulations, but then you get to apply it to labs, and you get to actually get your hands on pieces of equipment, and you get to touch the wind tunnel in the fluids lab and put on strain gauges and sensors for the machine design lab and all that great stuff. All right, so I don't want to bore you with the mechanical engineering curriculum. And again, I remind anyone that maybe is logged on late, feel free to type in the chat if you have any questions as I'm going. I'm just going to kind of keep on going until the end, and then I'll definitely have time to answer any questions you have. So, if you have any questions about our curriculum or any of that. Okay, so the first 2-3 semesters are going to be common amongst all engineering majors at Wilkes. So you're going to come in, maybe undeclared engineering or mechanical, electrical, environmental. You're not quite sure, did I pick the right one? That's okay. You sort of get a little exposure to all of them, especially kind of like third semester. You're getting statics, which is this free body diagram I showed you earlier. You're also getting exposure to electrical circuits. You've had some physics courses, some calculus courses, material science. You get a really good feel of, what is this particular major about and what are the other branches about. By fourth semester, that's when you really need to make your choice. And you have to, pretty much choose without losing a semester, do I really want mechanical engineering? Because pretty much all these courses you'll see in fourth semester are purely ME courses. Mechatronics, strength of materials, dynamics, thermodynamics, and machining. So basically by fourth semester you should choose. I'm currently teaching dynamics as a sophomore course, and I kind of had this epiphany this semester. It's funny, it's the 20th time I'm teaching this course, and I had this epiphany. The fourth semester also leads to the various major branches of engineering as a career. So my field by trade is strength of materials and solid mechanics and design. That's why I entitled this whole talk today, Engineering Design. So strength of materials is kind of that foundations course that leads into that field. You also have dynamics, which is how things move. That leads into vibrations, which is a junior level course, and robotics, which is a senior level course. So that's the foundations leading into that branch. Then we have thermodynamics, leading into the branch of fluid mechanics heat transfer, the HVAC systems. So these are all major branches that fall under the mechanical engineering umbrella. So, and now I'll go on to future semesters. You can see what it would look like junior and senior year. And now you're going to get a little more depth for these particular topics. We get into a fluid mechanics course, fluid mechanics lab, heat transfer course, heat transfer lab, vibrations course, vibrations lab, finite element methods, as I mentioned before, manufacturing and materials, that's another major branch. And then we offer what's called technical electives. So we like to give breadth and depth in our program. So you're going to get the breadth, where you get exposure to fluids, materials, machine design, robotics, but then you can get depth by taking technical electives in whatever field interests you the most. So you can take nano materials as a technical elective, or you can take advanced CAD, or I offer advanced machine design as a technical elective. So that's where we kind of give you a little room to create your own path. Where do you see yourself after graduation? Okay, and then the final thing I want to mention on this slide is our senior projects capstone project. So that's going to be your 7th and 8th semester, basically your senior year, and that's going to be an all-encompassing design project that you work on as a group. And I'm going to show you a whole bunch of great senior projects that I've seen along the way. I'm currently the coordinator of all senior projects, and it's such a fun experience. So I don't want to talk too much about that now. I'll talk about that in a little bit. Here's kind of a pictorial view of our curriculum. It's called a flow chart. And this is going to show how you can kind of move through the curriculum where you need to pass Calculus 1 before you can take Calculus 2. So that's called a prerequisite. So Calculus 2 would have Calculus 1 as a prerequisite. You see this hard arrow, solid line. Then you need Calculus 2 before you can move on to differential equations, and so forth. You need Physics 1 before you can take Physics 2. We also have some dash line, which are called co-requisites. So, and this is extremely important because the typical starting point for our students would be Calculus 1. That's this Math 111. However, if you happen to come in with taking pre-calculus your first year, it's not going to throw you behind. You can still easily graduate in 4 semesters because you can take Math 100 your first semester and then Math 111 your second semester concurrently with physics and concurrently with computer programming. So that's where these dash lines come in. So this was purposefully designed so that you don't lose a semester or lose a year just over one course, or if you happen to fail a course along the way. We give several paths. You potentially could take some summer courses, which I'm going to talk about in a little bit. All right, so this is relevant. So the math department basically sets the criteria which math you get into your first semester. And there's a placement test that you would take prior to orientation in the summer. If you score over 30 on this placement test, you're good to go. You're in Calculus 1, like I said, or your typical starting the flow chart. If you're in 18 to 29 range, that's Math 100, which is pre-calculus. You can still pretty easily graduate in 4 years. You may need 1 summer course to make up the difference. If you get below 18, you start in Math 94, which is college algebra. That historically was a trickier path, and we thought maybe we were losing a lot of students because there's some courses first semester you can't take, and that gets pushed back. And some students were taking a whole extra semester, graduating at 4.5 years, even 5 years. We worked through it within our internal departmental curriculum committee and came up with a way that students could still graduate in 4 years by taking Math 94, which I'm going to show on a later slide. Students that comfortably pass AP Calculus exam, so kind of if you're on the other end of the spectrum and you're thinking to yourself, hey, I'm already in Calculus 1 my senior year in high school. I'm in AP Calculus. I want to take the placement test. I'm hoping that I could place out of Calculus 1. Well, that's good because then you could just pick up with Calculus 2 your first semester, and that opens up credits for perhaps a minor later on, or even an easier semester if you choose, or different tech electives you want to take on. So that's kind of a decision that your individual advisor will help you work through, but if you have the chance to take the AP test, go for it. I highly recommend. I'm just going to briefly talk about the plan to graduate if you start with the Math 94, which would be kind of the lowest math you could start with and still pursue engineering. You're not going to be able to take chemistry right off the bat, so any of these classes that are in italics means that they're kind of out of sequence with the typical start, but you're going to see there's really not much that you're going to have to do to get caught up fairly quickly. By junior year, you're pretty much caught up. This was kind of an overlay from sophomore year, but it's not going to hurt you going into your senior year. And here's more of a visual pictorial of what it would look like if you came in Math 94. Basically, your first summer, you'd be taking Calc 1 and Physics, so basically 2 classes. And the next summer, you would take DiffEq. So that's really it. So you could come in with Math 94, 2 math courses behind, and basically just get caught up with 3 summer courses total and still graduate in 4 years. So, I think this is a very doable plan. I've seen some students actually come in with Math 94, Math 100, and graduate on time. So, keep that in mind. It's ideal if you could come in with Calc 1 first semester, but there's other ways you can get there. Okay, another thing you need to take, and this is all students at Wilkes, you have to take what's called Gen Eds. So there's 4 different areas. The humanities, you need 3 classes in this field: English, history, philosophy, foreign language. Basically pick 3 classes from that. Scientific world, we're way more than covered. We're a math, science heavy degree, so you're extremely covered. Social sciences, you need 2 classes out of this area. It's recommended that you take Econ 102, but you could also choose between political science, psychology, sociology, anthropology. And then you need 1 class out of Area 4, which is art, dance, music, theater. And this is every single student at Wilkes has to satisfy the Gen Ed, so that's nothing unique to the mechanical engineering program. It's basically 6 extra classes if you can do the math. 3, 5, 6, but it's built into the curriculum. Kind of going back, I'll go back to our first flow chart. You can see anywhere that this has a Gen Ed, 1, 2, 3, 4, 5, 6. Here's your Gen Eds that are already built into the curriculum. I think maybe it's worth mentioning how many credits per semester. That's usually a typical question I get. You could see your first semester 16, 17, then 18, 17, 16, 18, 14, 14. So 18 would be kind of the max you would go without being considered overload. You would need special permission to go over 18. 12 would be the minimum to still be considered full-time student. So you can see that, probably the average is around 15, 16, which isn't too bad. It's usually a pretty good mix of your technical courses, some labs, a Gen Ed perhaps, so we like mixing that up as you go. Okay, so we talked about Gen Eds. All right, you may have also seen on the flow chart, every single incoming freshman has to take this FYF 101. It's the only class that every single incoming freshman has to take at Wilkes. The only class. And there's a variety of different classes you can choose. You're going to be offered this choice in May. And I like having this open house now because I could give you a strong recommendation before you make your choice in May. I offer this FYF 101 Engineering Design, same title as today, which I strongly recommend for all engineering majors, especially mechanicals. And, it's kind of the introduction to engineering as a career. So we do some hands-on projects and some different discussions and lectures about the future of engineering, robotics, 3D printing, Internet of Things, how you control things with just your cell phone. Then I like to do some hands-on projects, competitions. We have an egg drop competition I tried one year, bridge builds out of popsicle sticks. My goal is to kind of make engineering fun for first semester, introduce you to what's college life going to be like. So when you get your choices of which classes to pick, highly recommend this one. If you come in as a conditional admit, which perhaps Liz could talk more at the end if there's any questions on that, you would have to take FYF 101Z, Intelligence Applied, and students are basically assigned to this and they not elect in or out of that. So that's, if you're assigned that, you have to take that class, but if you get a choice of all the 12, 15 different courses offered. Pick this one. Okay, another question we typically get is, what computer do I need? What laptop do I need? So, I know there's a lot of information here. This is going to be posted online later on. So if you want to go back and check this out, or if you want to take a screenshot now, it's fine too. But basically, it's kind of just showing, here's some recommendations from Wilkes IT. They're showing what kind of graphics cards you will want to use, what kind of hard drive. Windows is a better choice for your operating system over Mac for engineering students in general. And here's some recommendations from the faculty within our department. We kind of brainstormed. You want to make sure you get a machine strong enough to handle the software. If you choose to download it for yourself, MATLAB, AutoCAD, SolidWorks, the Microsoft Word, Excel, PowerPoint, the whole Microsoft suite. But it's not required that you have your own laptop to do all this high-end work. You probably at least want a laptop to do Excel, Word, PowerPoint, because there's going to be a lot of projects you'd be working on from home in your dorm of that nature. Typically, you could get to the computer lab to work on the other high-end softwares. So here's kind of another, if you want to take a screenshot of this. AutoCAD student version, SolidWorks student version, MATLAB student version, these are available for home use, but we also have our computer program. Students are given access to the software for the classes if they're able to install them on their own computers. Computer labs are available. This was something we actually added after the pandemic of last year, where basically all colleges nationwide shut down for half a semester and students basically were asked to work from home. You probably want to have your own laptop just in case remote work is necessary. We're all hoping nationwide that this pandemic ends completely soon, but it's probably a good idea just to at least come prepared with some laptop in case you need to work from home. All right, now I'm going to talk a little about my teaching philosophy, which is very typical of colleagues in my department. As I mentioned, for a typical lecture class, I go over the theory, usually on the projector first. I provide notes to the students so they know, okay, here's how do you calculate bending stress on a beam, sigma equals MC over I. Here's what all those Greek variables mean. Then we're going to do example problems on the whiteboard, where I do encourage class participation. I encourage all the students to have their calculators out, ask questions as we go. I had a professor once that said, you learn with your hands, not your eyes. So if you're just watching me do it and you're not doing it yourself, you're not learning. So I pause and say, okay, you work out these steps in your calculator. What do you get now? I'll call on different students across the room. Another typical question we always get, so I'm going to sort of head you off at the pass if you're thinking of it. What's a typical class size? For our department, we try to stick between 15 to 30, in that range. If we start getting over 30 for 2 sections, we may open up a 3rd section of the course. So, typically 20, 30 would be about max you'd see in a class, which is a nice number because I could still know everybody in the classroom. I get to learn their names, see their faces as they look at me. You can't really hide, You're not in a room of 100 engineering students, right? You're in a small enough classroom. And then when you start getting into the lab classes, they're even smaller. They're like 10, 12, okay? Every class I teach, I think, draws upon my experience as an engineer. I've worked as an engineer for 12 years and counting. I suppose I consider myself still an engineer. I like to incorporate a lot of group research projects, design projects, encourage creativity, collaboration amongst your peers. I like to encourage computer modeling, stay up to date on the current software. Hopefully we're 44 minutes into my talk now. Hopefully you understand what I think engineering is, what is engineering. But if I need to sum it up in one sentence, this is the best one I ever saw. Engineering is the practical application of science for the benefit of mankind. So scientists like to discover for the sake of discovery, and that's great. That's fantastic. I'm a nerd, if you haven't already surmised, and I watch shows on like how is the universe formed, and what other galaxies are out there. And these physicists are doing that kind of thing. How is the universe created? Engineers at the end of the day take this science, and we're trying to say, okay, what's the best computer and the way to transmit information and the best transportation and energy and best materials to use to make people's lives better, more entertaining, more efficient. So this is what we're always doing as engineers. This is also my personal philosophy. I think that a lot of my students I see entered engineering through one of two paths. They were either the gearhead in high school, they liked working on cars and tinkering with stuff, or maybe they were the theoretical, the book smart person, right? They excelled at physics and calculus, and they thought, hey, where can I go with this degree? Your goal, though, and I don't really care how you got here, it's wonderful you're here. Your goal should be to bridge the gap between these two. A truly successful engineer can do the theoretical work, but also get hands-on and turn some wrenches, right? And depending on your actual place of work, you may be asked to lean more towards one or the other, or kind of both. I was very fortunate when I worked at ATC. I got to do a lot of high-end analysis, but then I would put on my beater jeans and go get dirty and turn some wrenches, and so I kind of did a little of both. Put on my polo one day and kind of a greasy shirt another day. My goal is to inspire you all to invent, create, and excel in your life after Wilkes. This is, we're preparing you for the real world. That's what we do best. What makes Wilkes engineering different? I'm sure you're looking at other schools. Obviously, you're comparing around the area and even out of the area. What makes Wilkes different? Well, I mentioned it's, small class size helps, but we really are faculty that cares. And I know this is so cliche to put, but it's true. I honestly believe it. And this is why I came back to teach here, because when I was a student, I felt like my professors cared for me, and they wanted to help me succeed in my life after graduation. Wilkes is primarily a teaching school where your undergraduate education is emphasized. So we put a lot of effort and resources into what's the best way we can develop our bachelor's of science in mechanical engineering. How can we upgrade our labs and, hire the best professors that know what they're doing. And we're constantly looking on different teaching methods. So, we're truly, truly focused on our undergraduate curriculum here. Our students are well prepared for industry and graduate school. We have students that go on for PhDs, master's degrees. They get jobs immediately out of school. They get internships while they're in school, and that leads to full-time jobs out of school. Instructors that we offer hands-on experience. I know all the names of my students. My office is always open. People can come by all the way and say, hey, Dr. V, how's it going? Hey, I just want to ask you about this job opportunity, or what do you think about grad school? I'm happy to talk to them. So here's a fun picture. This is myself and my son, Eddie. He's the little guy, not so little anymore. He's about my size now. Getting dirty at orientation a few years back. We were doing community service. It was kind of like a morning activity. But orientation is fun because it gives like a close-knit community of your peers coming in, and your cohort you're going to go through. All right, I always like to talk about our grant we got. Actually, I got a video coming up. I need to stop sharing and reshare with sound. So, wait for a second. I probably should pick up the pace too. Wilkes was awarded a $3 million grant a few years back from the Commonwealth of Pennsylvania for 3 key labs: additive manufacturing, which is 3D printing, nanotechnology, bioengineering. So I got just a quick news clip to show on that.
Learning in a 21st century environment, a local university has a new state-of-the-art engineering department for students. Eyewitness News reporter Cody Butler takes us inside.
A crowd of more than 100 people came out to Wilkes University Friday to dedicate the new Mark Engineering Center inside the Stark Learning Center.
I went away for the summer and I came back and I was just totally impressed with how modern, this new wing of Stark looked.
Associate Professor of Mechanical Engineering Ed Bednarz says the newly renovated section has 3 new facilities, which include a bioengineering, nanotechnology, and 3D printing with new labs. creating a true state-of-the-art facility for current and future students.
Our goal is to get our students relevant jobs in their field when they graduate, so we want them to have their hands right in current technologies.
It's an $8 million investment in STEM education with a 23,000 square foot overhaul renovation. Randy and Robin Mark gave a leadership gift supporting the project. Randy has served on the university's board of trustees since 2013.
We have the opportunity to help inspire innovation and hopefully encourage success among the students.
Wilkes University's president, Patrick Leahy, says the country has seen a gap in engineering graduates, which he says has hurt the industry as a whole.
We as a nation need to educate more engineers in order to remain competitive worldwide.
The new renovations are a step in the right direction here in Luzerne County. In Wilkes-Barre, Cody Butler, Eyewitness News.
That project took 16 months to finish, and it was finalized in August. The construction was completed in many phases to avoid disrupting classes during the school year.
Okay, so yeah, like I said, I think I got to pick up the pace and give some time for questions, but here's a national ranking where Wilkes came in 25th nationwide out of 1,200 colleges in earning potential. And I always like this slide for a number of reasons, but mainly look who we beat out at number 26. Has anyone heard of MIT? All right, so here's kind of a nice view of our hands-on labs. The small class size allows our students to, get their hands on expensive pieces of equipment, learn how to use them, different things they could put on the skills they could put on the resume. We have a whole slew of labs. They're all listed here. And I kind of talked about them a little in our curriculum. This is the wind tunnel in our fluids lab, and microfab lab, nanofab, robotics, mechatronics, heat transfer. We also like to conduct research as part of our scholarship. We do have a graduate program. We have a master's in mechanical engineering and a master's in engineering management for anyone that is thinking about pursuing their study. We also have a bioengineering program in the electrical engineering department. Many of our students choose that route. They do the 4+1, where they do 4 years in mechanical engineering and 1 year to finish up their master's in bioengineering, so that's a possibility. But I like this slide because Wilkes is unique in the fact that we also conduct research with undergraduate students. So sophomore, junior, senior year, I'm working with students on my research. We're publishing papers, we're presenting at conferences together. So I'm not saying that we're the only school in the nation doing it, but I think it's a very unique thing. I think a lot of schools, they rely only on their graduate program to conduct high-end research, but we like to involve our undergraduates. And this is a fun picture because it's kind of showing a simulated force transducer, which was that big bridge crossing simulator I showed earlier, showing kind of the toy train with a variety of sensors. Here's sort of a view of my lab, kind of during peak time at the end of the semester, where I had some senior projects going on. I had research going on, outreach event. You could see kind of a toy on the end. On the right there, I'll talk about that. I want to talk briefly about our internships and co-ops. We highly encourage students to get their foot in the door in companies while they're going to school. It's great. It's something to put on the resume, for one. So it helps to have the degree, but also some experience while you're in school. And also, there's a lot of companies that they invest the time in you while you're in school, and you start there junior year, then you work there again senior year. By the time you graduate, they say, hey, you want a full-time job? A lot of our students, that's kind of the route they go. Or it's a good way to try out different jobs. You could work more in a prototype facility 1 year, work in a manufacturing facility another, work with HVAC, then work with robotics, right? So you can kind of play around with different companies. And majority of our internships are paid, regardless if you take it for credit or not credit. It's always kind of a common question we get. And there's just some of the companies. There's a lot of companies in this area, believe it or not, that love hiring Wilkes engineers. Actually, we have a great rapport with them. And we couldn't do this without Sharon. Sharon Castano on the right. She was interviewed. KRZ, celebrity Amanda on the left. And she helps day-to-day work with our students on resume skills, interview skills, helping applying to jobs, getting their name out there. So she's fantastic with her department. We also have collaboration with local companies. This was undergraduates I worked with. We worked on a design project for them. They partnered with Ben Franklin, this company, Mound Productions, in order to partially fund it. And it was a great opportunity for our students. They got independent study credit and also got something really cool to put on their resume. They got real world design experience, and they designed and built that wash station you see in the back. We have graduates going all over the country for work. Here's Adam and Andrew. They're both working at Toyota in Michigan now. So that was their dream, to work for a car company, and they're working for American Toyota. So that was great for them. We like participating in outreach events to middle school students, high school students, as part of the Adventures in Science or Women Empowered by Science. And it's just a great way to kind of showcase what is engineering to kids. You know, it's a way for us to get back to community. I have a kind of a demonstration of a Rube Goldberg machine on the left. They're allowed, play with some toys, which, kids don't think of toys as engineering, but hey, if you're creating something that doesn't exist, that's engineering. They're building these different marble tracks and the car tracks and having fun doing, what is actually the seed for engineering later on. Here's, just one of the STEM Discovery Days a couple of years back. I like this picture. My son happened to make the brochure. He's the one with the wide-eyed smile. Like I said, he's a ninth grader now, so he doesn't. Oh, Dad, you're embarrassing me. But here's the FYF class, part of the egg drop competition. Funny, they're all seniors now, so this class was a few years back. Here's I promised I would get into senior projects, and then I'll have some time for questions. One of the senior projects I worked on that was really great was this adjustable wheelchair. It was actually an idea by my wife, Heather, who's a licensed occupational therapist. And it's basically a way to create a continuously adjustable wheelchair to help patients. And, so that led to my fourth patent. My fifth patent came from a student project, a pressure redistribution system, also my wife's idea. But the cool thing is myself, my wife, and these students are all partners now. We all got patented together. We're all inventors. We're all trying to license, sell it. So a lot of these senior projects could lead to careers and companies. I had a team design their own 3D printer, so that was really cool. There's a great picture of myself and my wife holding our patents. And like I said, we're all co-partners with my former students. Here's a real-world project. We worked on a church, an old church converting into a parish center. So they got real-world experience working with customers. They got to redesign pews in a creative design, did some strength analysis, did some acoustics analysis. A lot of great logistics they had to work through. This is us just doing some testing on the bench. I'll just show that quickly.
1, 2, 3, go.
And we put some strain gauges and watched how they bounced up and down. So that was fun. Here's what a typical senior projects presentation would look like at the end of the semester. So you see, all the students, they dress up nice and they present in Spark 101, which is the huge lecture room. And it's very rewarding and fulfilling as a professor, because I watched a lot of these students come in as freshmen, and they're like, I'm not going to ever be able to present, and I don't know how to do a talk. But then, like, by their senior year, they've gotten enough exposure to communications and presentations that they're standing at their coffee and be like, hey, look, this is what we designed, this is what we made. So it's wonderful watching them grow, as they're about ready to enter the workplace. Here's a couple just projects to show. Pumpkin chunking on the left, that was a fun one. This high lift dump trailer on the right. I know I'm running out of time. This team, a lot of these projects, they come from students themselves. You know, I like letting the projects grow organically. This team, they wanted an automated drink mixer for a bar. So they wanted a way that, you know, a bartender could just say, push a button and say Long Island iced tea, and different shots that come from the different liquids. As far as I know, that wasn't actually alcohol for the day of the presentation, so it was just colored liquid. But that was a fun project. We had a Rube Goldberg project, which is a very complicated way to do a simple task. If you haven't already Googled Rube Goldberg, it's fun. This team unplugged. They found a way to charge a cell phone in the woods by hanging a weight from a tree and letting the gravitational potential energy transfer into kinetic energy, which turned the motor and transferred to electrical energy. So that was a great project they came up with. Kraken Board Sports, they're kind of one of the you know, teams I showcase all the time. They wanted a way to snowboard on without hills and to wakeboard without boats. So they designed this winch system. And they actually did create their own company. They're selling these units up and down the East Coast and having fun, a lot of fun with it. Here's just a quick video of them taking my son for a ride using their winch. It could go much faster than this, but yeah, so that was them taking the thing for the ride. Okay, I think I'm right on time, so we should have some time for some questions. Forgive me, my voice is gone. I'm talking so fast. Wilkes will give you the skills necessary to be a successful engineer. College is different from high school, you know, no lie about that. You get a lot more freedom. With freedom comes responsibility. My advice is to seek help if you're falling behind. There's plenty of tutors, classmates, professors want you to succeed. And then just leave with this quote from Steve Wozniak. He was the other Steve in Apple, right? Everyone knows Steve Jobs, but Steve Wozniak, I hope you'll be as lucky as I am. The world needs inventors, great ones. And you could be one. If you love what you do and are willing to do what it takes, it's within your reach. And it'll be worth every minute you spend alone at night thinking and thinking about what it is you want to design or build. It'll be worth it, I promise. Okay, so I know I did a lot of talking, a lot of information. I suppose I could start with the chat. Let me break out the chat. It looks like a question first to Liz, going back from Zach. As far as admissions, if my son has decided to accept Wilkes, what are our steps?
So your next steps would be to make the deposit. So once we have that deposit, we will secure your enrollment to Wilkes, and then that would get you in for the class of 2025. And then after that, you'll just move in through some steps of, like he said, doing the math placement exam, getting housing situated, anything like that too. So you can make those deposits if you guys are interested. We'd love to have you right through your application portal on the Wilkes application portal, and you can actually just make it right through there. And then we'll get it, and then we'll get the confirmation within about a day.
Okay, yeah, so thank you, Liz. Any other follow-up question for that? Okay, and then how welcoming is Wilkes to accepting college credits earned in high school that are specific to engineering as well as math and English courses? So I don't know, Liz, if you want to take that, or I could try my best.
Yeah, so we are pretty transfer friendly too, especially within those science and math credits. What I would say is that when you are finished with those credits, say this spring semester, you'll send in your college transcript to Wilkes, and we will actually review those at our admissions office and see where they will transfer into your program. English credits, the only thing I will say that we do offer a 4-credit English class here at Wilkes. So if it's 3 credits, you'll just have to make up that 1 credit. We have a credit waiver program. So just make sure, what I just say is just make sure you get in those official transcripts from the college right to Wilkes, and we will review all of that for you.
Okay, yeah, and I just put it in the chat. Feel free to type or ask any questions. I'm willing to stick around as long as we need to.
Yeah, and I think if you wanted to go to the bingo, that will be starting in about 5 minutes. I think there's some really great prizes, so learn a little bit more about Wilkes. There'll also be some current Wilkes students there too. So if you're interested in asking them some questions, learning a little bit more about residence life at Wilkes, that's a really great opportunity too.
Okay. Anybody have any other questions? So let's put last thing. Thank you for your time. Thank you for listening to my talk. I put my email address here at the top, edward.bednarz@wilkes.edu. Feel free to reach out to me if you have any other questions about the mechanical engineering department. Okay.
Thank you, everybody.
Okay. Thank you. Thank you, Liz.
Yeah, no problem. Have a good one. Thanks for everything.
Okay, you too.